Hi, so I'm Fraser Lewis. I'm from the Fawkes Telescope project in Cardiff in Wales, and in today's presentation I'll be talking to you about a project called lascil. And lascil, as you can see from the title, was defined as cutting-edge online tools in astronomy and planetary science for a post-pandemic world. It was a European Union Erasmus Plus program which ran from June 2021 until June 2023. As I say, I'm part of the Fawkes Telescope project. I'm also part of a sister company called FTP Europlanet, which is based in Germany. And I also work with the National Schools Observatory in Liverpool and the Open University, which is a distance learning provider in the UK. Our telescopes, so we have a couple of telescopes here as part of the Las Cumbres Observatory. We have a couple of 2-meter telescopes. They are marked on the map here in the red dots. One is in Haleakala in Hawaii, and the other is in Siding Spring in Australia. I've also marked a third telescope on the map, which is a yellow dot, which is the Liverpool telescope on La Palma in the Canary Islands. These are all 2-meter optical telescopes, so they're very large collecting area telescopes that work in education, or that work with a percentage of their time in education. We're also, as part of the Fawkes Telescope project, we're a member of or we're part of the Las Cumbres Observatory group, and we are able to use Las Cumbres Observatory time on their network, which is not just the 2-meter telescopes, but 1-meter and 40-centimeter apertures as well. They are very good telescopes on very good research sites, and that allows us to do, as you might imagine, some very good and interesting astronomy in using robotic telescopes. So lascil itself stands for Large Scientific Infrastructures Enriching Online and Digital Learning, and it was a Erasmus project, as I said, Erasmus Plus project, as I said, comprising of 5 partners, 2 partners based in Greece, EA and Fourth Skinakis Observatory. So EA are based near Athens, Skinakis Observatory is on Crete. We also worked with longtime collaborators, Nucleo, who are based in Portugal. In this occasion, we're Dill Fawkes Educational Trust, but that's synonymous with Fawkes Telescope Project. And we also worked with the OVF, which are based in Austria. As I mentioned, the project ran for 2 years. It was pretty successful in doing everything we said we would do. I've put some numbers on this screen just so you can kind of see what we were trying to do. So in a sense, we looked during and post pandemic, everybody moved online, and everybody kind of discovered for the first time data archives and the idea of big data. I say for the first time, obviously that's not entirely true, but we certainly sort of made better use of these archives at that point. By big data, you can think of things like the ESA Gaia mission, James Webb Space Telescope, which has recently launched. In the radio, you have the Square Kilometre Array. Coming soon in Chile, you have the Vera Rubin Observatory, which is an optical survey telescope. And of course, if you move from astronomy into sort of the broader physics field, then for many years now, we've had CERN as well. All of these observatories, all of these facilities are producing huge amounts of data. We are talking sort of from terabytes through to petabytes and even exabytes in terms of the amount of data. It's not always useful for science for sorry start again it's not always useful for educators in its current format, because of course it's built in a science data archive, and sometimes these things are a little bit difficult for students and teachers to penetrate. So that's sort of what we were trying to do here, was look at these big data facilities, these data archives, and trying to discern how we could provide resources for teachers to access these. So we created initially a set of what we call tools. They are 2 or 3 page PDF guides on different aspects of astronomy, different pieces of software, different websites, and we created 30 of those in the first few months of the project. From those, the 5 partners then created a further 30 what we call demonstrators, or you can kind of consider these as lesson plans, or scenarios is often a term that's used as well. So we created a further 30 demonstrators, and then in working with our teachers, they were able to create a further, with our guidance, they were able to create a further 48 lesson plans. And many of those lesson plans, of course, linked with their curricula. So again, we're looking at Greece, UK, Portugal, and Austria for those. And the idea, again, is the primary aim, as you see at the bottom there, is to allow teachers to capitalize on students' interest in science which of course we kind of hopefully take for granted in some respects, but we should always cherish that, and to understand how these teachers and students can progress, particularly the students, of course, with careers in, not just in astronomy, but in STEM in general. So that's the broad remit of what we were trying to do, which as you might think is you might imagine is quite ambitious. Um, as part of this, the Fawkes Telescope contribution, one of the Fawkes Telescope contributions, was 6 PDFs. These are 6 tools, if you like, and each one of these is based on a different aspect of using the Las Cumbres Observatory network. So planning and observation, and creating observation requests through the simple interface, creating observation requests using what's called real-time mode of the telescope, accessing the data archive, which of course doesn't just contain the images taken by that particular user, but by all the users, and then downloading those images. There are many other tools involving software such as lascil.eu, where you can then download the FITS files and examine them, make color images, make some measurements based on those as well. There is a web link there at the bottom for the zipped file for those. I would encourage you to have a look at those if you're interested at all in what we were doing there. We created, in fact, I've been a little bit selfish here and produced the demonstrator, or talked about the demonstrators that I created, which is by no means suggesting that they're the better ones. They're just the ones I guess I'm most familiar with. So these are based on some of the science that I work with outside of the project as well. So we took the Gaia alert stream. So Gaia, as you may well know, is the European Space Agency mission, which is mapping the shape and structure of our Milky Way. But as part of the secondary science aims, it's creating an alert stream where it spots objects that have changed in brightness since the last time it looked at that particular object. Those targets may include things such as supernovae, flare stars, variable stars of lots of different flavors, and even black hole transiting systems as well, in terms of microlensing. So we created a series of demonstrators. These are sort of, if you might imagine, 12 or 14-page PDFs. They also exist in online form, which is the one that we sort of point you at here, where you can skip through the different parts of the activity entirely online. And we would encourage you again to have a look at those. So that was one we created, where we looked at the Gaia alert stream and tried to translate that into what would make a suitable target for a student to observe using the telescopes, and would they understand what they were doing as well, because obviously that's a reasonably key part of what we're trying to do. The second demonstrator that I created is on a vaguely related theme, I suppose, which is looking at open clusters. So groups of stars in our galaxy. There are about 1,500 or so known open clusters in our galaxy, and several hundred of those have not really been studied very extensively at all. So again, there's a guide here to how you might want to go about finding an open cluster, taking an image of it, and then doing something with that image. And in this case, the doing something was to use a free photometry tool such as lascil.eu or such as Makali, which is produced by the Japanese astronomers and educators, using the photometry tools from those pieces of software to create what we call a color magnitude diagram, which is very broadly the same, I guess, as a Hertzsprung-Russell diagram that most astronomers will be familiar with. So again, that was a demonstrator that I created, and hopefully that was something that's been useful to many, or some, if not many, of our teachers. I'll provide you with some links there to some numbers. I mean, again, these are numbers that we are sort of required to report for the project that's just finished. They match and meet and exceed in pretty much every case the numbers that we predicted we would go for. And of course, this was during a COVID time, so it was all a little bit up in the air as to how these things would pan out. But we reached several hundred teachers. We reached over 1,000 students. Each of the 5 partners hosted events in their own countries that were available to their own teachers. And in addition to that, there were 2 fantastic week-long, I call them summer schools. One of them was in summertime, one of them was in February, and they were in Crete in Greece and in Alceva, which is a dark sky reserve in Portugal. In total, we had 67 participants, so lots and lots of teachers. And our website then provides us with a legacy of the work that they created, as part of those summer schools, in addition to the work that we'd already created as well. So again, all of that material is free of charge, whether you're from the European Union or from one of those participant countries or not. I would just say you can't really quantify it, and it's something that we may come up in the discussion, I guess, as well. But you have those kind of anecdotal um, things that you speak to teachers about, and teachers say how much they enjoy working with other teachers, discussing their common problems, discussing problems with teachers from different countries, and coming up with solutions, seeing how other people do things. Again, as like I say, you can't really quantify that, but it's certainly something that we were aware of, and we're hoping to be able to work with many of these teachers in either in other Erasmus Plus projects, or just in a more independent basis. Um, as part of our remit to produce the report at the end, we have to produce several results. These are sort of Erasmus Plus kind of staples. So we produced a teacher training framework with a plan, which was relatively early on in the project, to look at the needs analysis of teachers, where we could best help them in terms of COVID and post-COVID world, which, as you might imagine, was a fairly open-ended question and answer. We created an assessment toolkit. There's a very, very detailed analysis conducted by some of our EA people on the students and teachers, using questionnaires and using less formal methods of feedback as well. And that's a very extensive and interesting document to follow. And there's also a roadmap which looks at our project outcomes and suggestions for best practice for future projects. Those, I believe, will go live on the website in the next couple of months or so. We're just in the phase now of waiting to get the go ahead from our agency. But in the meantime, if any of you are interested in any of those documents, then by all means contact me, and I'd be happy to forward them to you. Like I say, I'm happy to sort of contact you and be in touch with people if they have any questions about lascil or any observations on the project. I would be very grateful to hear from you. And here are a list of contacts and web links related to today's talk. Thank you for listening, and we'll speak to you again in the roundtable part.